All right. So we're here to talk about quantum computing. Quantum computing harnesses quantum mechanics to perform computations far beyond classical capabilities. It uses qubits, which can exist in multiple states simultaneously, and this enables parallelism. And it's this potential that allows quantum computers to solve complex problems way more efficiently than traditional means. And it's this advancement that is already revolutionizing fields in cryptography, material science, and even healthcare. This demo is being streamed simultaneously on X and YouTube. So please, everybody, I would appreciate a follow, like, and subscribe to this channel. Leave the comments during the stream, and we'll try to answer them as we can. And today, I have the pleasure to be speaking with 𝘂𝗽𝗓, who has 15 years of programming experience, and he will lead this demo. He has a strong background in server management, portal design, and database development. 𝘂𝗽𝗓 is skilled in creating comprehensive digital display solutions and communication systems. Dynex combines neuromorphic and quantum computing to enhance computational efficiency. And it actually leverages GPUs to emulate advanced neuromorphic circuits. And it's this approach that solves complex real-world problems with improved accuracy. Dynex aims to drive this innovation across various industries with its revolutionary platform. And 𝘂𝗽𝗓, thanks again for being here and walking us
thanks for having me.
Like such a complex topic. I mean, I can wrap my brain around something being in multiple states simultaneously, but it's always good to have an expert with us.
No, honestly, I really enjoy actually getting on sort of interviews like this where we can get into the bit of the weeds of what Dynex is doing and a bit more of the background, but also we really want to start showcasing more and more what Dynex is capable of in multiple sectors.
Yeah, so I'm here on the website. Maybe walk us through this a little bit.
Sure. So some of the use cases that obviously are quite well versed around quantum is pharmacy. We've showcased a few different sectors recently, actually, from quite ranging like various sectors in from, I would say, automotive is a big one. We recently did CFD at the beginning of the year. Pharmaceutical is a massive one. We've already showcased some RNA and protein folding for, and we've had great talks with a lot of people in that industry. When it comes to computation, pharmaceutical computation these days is probably one of the biggest loads on those type of systems, right? And that's only going to get bigger and bigger and bigger as time goes on, and more compute is actually required. And it's one of the reasons why we think that, or it's not so much we think, we know that we've got a network that's capable of handling that kind of load on a regular basis. So that I believe that's you've just got to the protein folding and then RNA folding as well. They're fascinating subjects from a compute perspective, right? RNA folding is a lot easier on compute than protein folding, but trying to actually do all this in a quantum environment, it's been a really interesting challenge for all of us, right? We're not all specialists in, pharmaceutical areas, for example. We've got people on staff who are more versed than others in that industry. Just like myself, I've got some experience with the automotive sector. So we all bring something to the table when it comes to our backgrounds. And, you know, we still want to learn more. We think that there's endless possibilities around what Dynex is capable of doing. These are just a few examples.
So you mentioned that your background is more in automotive stuff. So I've got the automotive and aerospace stuff pulled up.
So one of my
go ahead.
I was just about to say one of my longest running projects has been working with the automotive industry. So when I was brought in to give some conceptual ideas to Dynex very early on, the first thing I actually came with was, let's have a go at doing CFD, or computational fluid dynamics. For anyone who doesn't understand what that means, it's how air and liquid interacts with an object, or at least that's in its rawest term. But yeah, I mean, it was one of the first things I suggested, and along with one of the other Dynex coders, Sam, who's our head of actual quantum architecture now, we managed to successfully get CFD running in a quantum environment. And it's opened up a lot of doors. Legitimately, it's opened up a lot of doors. And what you've got in front of you there is another door that's currently just being opened.
So maybe expand a little bit about what makes this stuff way better than traditional supercomputers. For instance, like with this vehicle routing stuff, like whenever planners are like city planners, for instance, are developing a new roadway or even like a highway stuff, like what a lot of people don't realize. I remember there was maybe it was like 20 years ago, people were talking about trying to solve traffic problems. It's a huge, complex issue. And what a lot of people might not realize that, if you're driving down the freeway, if the slope of the road changes even by 5 degrees, either up or down, this causes people subconsciously to slow down for whatever reason. And, this can have like an accordion effect, right? On traffic. Or even if the road narrows or widens even a few degrees, it will cause people, to slow down. This is one of the reasons why maybe if everything was automated, like you wouldn't have that, because the computer would know, I don't need to slow down because the slope of the road changed 5 degrees.
Sure.
Yeah. So maybe walk us through what makes your platform better than, for modeling, better than like traditional stuff.
Sure. I mean, the first and foremost, not every problem is actually better on quantum, right? There's this misconception sometimes that people believe that quantum is the ultimate solution. Unfortunately, we're not quite there yet. But a lot of it can be, right? Especially optimization problems. Specifically, optimization problems are really they're fantastic showcase pieces for quantum. So while I'm explaining this, I'm just going to set this running a minute so that it can run off in the background while we're chatting. But so
and for those of you who don't know, sorry to,
go ahead.
Yeah, I just, for those of you who don't know what just happened is, even though the map might have looked the same, I actually switched it to Cliff's screen. So we're going to have a live demonstration of everything.
Actually, we got 3 that we can demo. I'm more than happy to demo each of them to you. Like I really enjoy showcasing what Dynex can truly do. And what this is, for anyone who doesn't understand what TSP is, or traveling sales problem, is take a lot of different locations and optimize a perfect route so that It's the shortest amount of distance for the short amount of time. Ideally, not crossing over any of your previous pathways. What we did with the multi-vehicle routing problem was effectively go one step further and make that into a multi-TSP. So it's not doing one route right now. It's doing 4 at the same time. And that's something that you won't obviously see with classical type of compute. It has to work in the same confines as the CPU does, where it's 1 in, 1 out for input and output, right? It does it at super lightning fast speeds, but it still is 1 in, 1 out, and always will be. Whereas quantum and parallel processing really opens the door to go at it all at the same time. So instead of working out each of those 4 routes individually, it did it all at the same time and was able to work out. So the problem there is 4 vehicles, 60 locations. There's a depot with a certain amount of goods in it, and they have to be distributed across all those 60 locations. And obviously dealing with things like road conditions, whether a road is one way, speed restrictions on those roads. So there's around, just for that alone, is about 400 constraints or the rule set, shall we call it, of what it's got to do and how it's got to do it. And that's where quantum really shines, right? I was saying to you just before we jumped on air, was that the more you feed quantum, the infinitely more efficient it becomes at doing its job, to the point where we could crank this up to 10 vehicles with 100 locations, and it will actually finish the same time, if not quicker, most of the time, just because you've got infinitely more data to feed that computational load.
And how long would that take on like a regular computer, and then how long would that take on some of these supercomputers that are?
So I mean, a regular PC doing it, just your run-of-the-mill average sort of work PC or home PC, I would say doing 4, maybe a couple of minutes. A supercomputer is going to be around a minute, and we're at around, well, actually, I can tell you. 3.5 seconds. So
Yeah.
it almost sounds laughable. It is really, right, when you talk about like how compute is calculated. Generally, most of the time, our jobs take longer to actually pre and post process than actually doing the computation, because once it's on the network and running, we're at exponential speed at that point, right? With our network. When you're doing pre-processing to send the job, that's on your local machine. So that's dependent on what your machine's capable of doing. And the same when you render out or you complete the computation at the other side, the post-processing. And again, that's obviously done local side. So it really does go to show what quantum is capable of doing when you really push it. And 3.5 seconds to calculate, I think the variable size is 240 variables. So yeah, it's 240 to the power of 4, because each vehicle is its own set of problem sizes. So yeah, it's 240 to the power of 4, or times by 4, to be fair. But it really goes to show you that there are perfect opportunities for quantum to exist on a more accessible area, right? I don't know if you've looked into like the costs of generally how much access to one of these sort of machines actually sets you back, but usually you pay by the hour.
Okay.
And it's
for like a supercomputer,
for a supercomputer or a quantum computer, right? The quantum computer doesn't become available to you straight away. Usually there's a couple of months wait list for those. But supercomputers, you can go and rent big supercomputers for a couple of hours if you really wanted to, and most of them are fairly available these days. But when you're thinking about how time is money when it comes to like having these solutions available to you, that's where this becomes very attractive, right? Because if you can finish one problem in 3.5 seconds and you're paying already for that hour on a supercomputer, how much more can you achieve if you can squeeze, 50 jobs into the same slot as one job on a traditional machine? And that's where you obviously start reducing your overhead and your overall costs.
Yeah, it scales out, that
Yeah.
way. And a lot of people might not even be aware that, now it seems like supercomputers are all over the news, but, in places like California, I can think of at least 5 quantum computers that have been live for several years now at research institutions.
Yep. I know of at least 4 out there off the top of my head. And like that's something else that we're very much aware of, right? We're not trying to claim we're a physical quantum machine, right? Because that'd be quite naive of us to think that people wouldn't be able to work out for themselves that we don't actually have a physical quantum machine sitting there doing all these calculations. What the benefit of what we've built is that we're able to emulate the same environment, which allows us to then run quantum algorithms on a traditional piece of hardware. Now, the tech for that is not new. The tech for that has been out for 4 or 5 years now. The bit that's really interesting is how our dev team has managed to actually be able to deliver that across a blockchain and a distributed network. That's the real special part to Dynex is how that network all talks to itself and makes sure that when a job comes in, it can actually retrieve that data and know where all those data packs are going and how to basically put them back together.
Let me see if I can. I'm trying to look at your guys' website because you have a. Don't you have an Explorer that shows all of that?
We do.
Stuff? I mean,
we do actually. I can bring it up on mine if you'd like. I can bring it up on mine.
Yeah.
So we actually have
maybe just expand on that a little
Sure.
bit, because that's one of the amazing things that I've been incredibly bullish about distributed ledger technology. Everybody's right now. It seems like most of the talking heads and oxygen has been consumed by cryptocurrencies, but cryptocurrencies is just a sliver of what's possible with distributed ledger technology.
I actually agree. Like blockchain in its own right is not just cryptocurrency. Like you said, cryptocurrency is one small slice of that big, ginormous blockchain pie. And we're now showing that actually there are other things that can become about, right? It's why we're seeing now DeepIn take off as a fairly strong narrative. We're seeing things like running AI or large language models directly on chain, and your rights to use it are all bound by how you put it on the chain in the first place. It's really interesting to see what blockchain is becoming, because we're not just all about payments anymore. I would say the first 5 years, it was just a payment solution, right? I don't know when you got into Bitcoin, but when it was first around, it was just all about the money aspect of it. But slowly but surely, people have realized there's so much more that can be done on a distributed ledger.
Yeah, I mean, it just opens up so many possibilities. And now with all of this stuff coming online, especially with artificial intelligence, we're going to need blockchain for the additional security. And it opens up avenues that aren't even really possible now with machine-to-machine communication and payment systems. That just aren't currently available, and the current infrastructure doesn't support this type of application.
Yeah, I think you're absolutely right in that respect, right? I think that cryptocurrency still has a part to play in blockchain, right? There will always be those other metrics that people want to look at. I don't disagree. But I love to see when people push technology in directions that they're not meant to, or were never envisioned to be pushed. It's one of the big fundamental things that I do at Dynex. I do a lot of conceptual work with Sam, the head of quantum architecture. And, Sam, for better or worse, he hates me at times with some of the mad ideas I come up with. But if we're to really find out where the limits of quantum could be, you're going to need a really big quantum system in order to actually find that out. And so far, nobody's been able to build one, right? Not in a physical sense. I think the largest amount of qubits is 1121 currently. Obviously, D-Wave has around 5,000, but they're very much in the same boat as we are. They emulate a solution that allows them to do quantum algorithms on their own systems. So they've got about 5,000 qubit, but that's really not even enough computation to really find out where the limits are.
Yeah, and so you have the map open right now. How many miners do you have on the network right now?
1 second. 127,887 right now. That's currently live. That updates literally every minute. So it's a fairly large.
How accessible is that for? Can anybody be a miner?
Yeah, absolutely. We actually have one of the lowest requirements for doing proof of useful work concept type jobs, right? Where we're not just doing blockchain, we're doing obviously computational load at the same time. A lot of people have to disconnect from one chain to do the job and then reconnect to it again afterwards. We took a very different approach. We took very much a quantum approach, right? We entangled our network. So we actually have our POW on one side of that entanglement and our POUW, which is our jobs, on the other side of that equation. And one will not work without the other. So it's a true, in its rawest term, an entangled solution. And eventually that will get to the point where we're going to push that so tight that the entanglement won't be able to be seen. It'll all be considered one at that point. Even though it's two separate solutions, it will act just like one solution. So
yeah, that's amazing. And moving forward, I think that what's going to be front and center is projects like yours that take this approach. I think we're slowly seeing utility crop up to be the front and center, and the sort of wild west of blockchain is dying out. Another thing that I like about your platform is it was a fair launch, and moving forward, I think that we're going to see a lot more people take this approach because it's just that I mean we've seen what happens with people that get a substantial amount of the supply in the beginning. It ruins everything. And as an investor, it's a little bit frustrating when you see, the people that are behind the project, dump on the community. The other thing that is great about you guys is, if I'm not mistaken, the platform was actually live before the token was. So, I mean, you're actually showing that this stuff isn't smoke and mirrors, right? It actually works.
Yeah, I mean, so we did 2 years of development in-house before we even launched a blockchain. We were going to go down the route of running our own FPGA farm effectively to do this ourselves. We quickly realized that to scale that, would have been in the tens of millions of dollars worth of infrastructure. As you can see there on the screen, it says that based on rough prices, our GPU total would be the equivalent of nearly 30 million. That gives you some kind of idea of what it would have took to actually build out a network of that size. And once we'd realized that blockchain could give us that benefit of having a fully unified ecosystem, right, where miners are being paid for the jobs they're doing, customers are bringing in money, which is then converted over to Dynex to pay the miners, and then we obviously take our revenue from the subscriptions and jobs. We don't take from the block rewards, though. That's the one thing we don't do. We only take from the enterprise side of the business, and we quickly realized that actually it was a really good model. We've had some troubles over the time trying to make sure that this thing runs exactly how we want to. We've had, times where we've hit roadblocks and thought why, and then a couple of days later we finally figure it out. Like, we're a very large team. Most people don't realize this, but we announced our leadership team. That's like 10 people, but actually Dynex is a team of 50 now, and that's quite a large team for any kind of business in crypto these days. Usually they're less than 20 people, most projects, to be quite honest.
Yeah, and getting back to the tokenomics a little bit, and the new model that you guys opened up, that brings in some interesting possibilities. And you guys aren't the only ones that have done this. There's another company called 𝘂𝗵𝗶𝘀 they're a decentralized advertising exchange, and most advertisers and publishers, they're not going to buy up crypto, so they're paying in fiat for the services, and then 𝘂𝗵𝗶𝘀 takes 100% of that revenue and they use it to buy back the token. So maybe explain a little bit about the benefits of doing it that way from both sides, right? Like, why this would be advantageous for a business, and then as somebody who's holding Dynex, like how I could benefit from a company paying fiat versus using the token.
Of course. I mean, that's a really good question, right? Like, how's this all work, right? And the best way to explain it is that there are block fees that come as part of minting a block in any respect of any blockchain, right? There's block fees and block rewards. The fees are generally a combination of all the TXs that are in that block for the transactions. Well, what we've managed to do is actually have our own solution that can add our job fees for our network in as actual TX fees, thus keeping the analogy of an entangled solution. Now our marketplace is entangled with our own blockchain to deliver those fees. What does that mean for the miners? Well, obviously we're on a declining emission schedule, meaning our blocks are dwindling in size from a reward perspective. I think we're still 2 years away from hitting zero, but by then we would like to have all of our subscription models live, customers onboarded, and effectively we're replacing the block rewards by the block fees at that point. And then, we don't even have an emission schedule at that point, because the subscriptions will just offset those block sizes. So we could see a complete reset of how many Dynex per block are actually given out. So our original starting point was like 450. We could potentially see, again, 450 Dynex blocks being mined, not because there's a reward, but because of the fees. And that all comes down to the fiat on-ramp. Like you were saying a minute ago, right? Big businesses don't want to deal with crypto. They don't want to go on open exchanges and have to buy up liquidity just to be able to pay for a service, right? They want the AWS style, shall we call it, where they put their bank card in, they hit pay, and then 5 minutes later they can get going. They don't want to wait around. They don't want to have to mess around with other services. They just want to come to you, pay you their money, and get cracking, basically. So we realized very quickly that we would need a fiat on-ramp. It took some time to get that over the line, because there's a lot of red tape around any sort of blockchain business using fiat for payments. Certain companies won't touch you at all, which obviously is something that we had to deal with, right? We've sorted it out. We got our fiat on-ramp, and now we're able to offer proper subscription packages. Actually, you just hit the nail on the head there. And it, you know, we start our offering at $99 a month, not hourly. We're not charging hourly for access to our quantum network. We're actually offering it based on a monthly retainer, whereby you get so much resources dedicated to you as a client. And for $99 a month, that is a great introduction into any sort of quantum learning. You know, we've had a few academia people who wanted to use it, because obviously that is a lot cheaper than going and renting something from the college or the universities. And it really does lend itself to open the door and lower the barrier, right? For too long, quantum's been way too expensive and way too inaccessible to everyone. That's something that we're aiming.
$99 a month. I mean, people spend probably more money a month on lunch than that. So for this, for instance, like for somebody who, you know, might not have any idea what this means right here. So for $99 a month, like what are the types of things that I could do on your platform for $99 a month?
So technically you could still run anything you like. The only bit will come down to speed of finishing, right? Because if you've only got 1,000 quantum gates, once you hit that 1,000, you can't go any quicker, right? It'll just take a little longer. Obviously, if you've got something like 1,000,000 quantum gates, then you basically can go full bore, hammer to the whole thing. It won't matter. It'll just keep going. But each user has their own queue, basically, of within their own subset of resources, right? So if you've got 1,000 gates and you're currently using 950, and your next job needs 100, it's going to queue that up until your previous job allows you to reach that requested amount.
So if we could switch up a little bit, I'll
Sure.
put back up to your stage here, and maybe like show us one of the other demos that you were going to do, and maybe like you know, maybe explain why somebody would want to do this, and you know, like for the 1,000 gates, like what you could actually do.
So let's put it like, let's give it a bit of a challenge. So I've just adjusted the factors, right? So I've asked for 80 employees with a max consecutive shifts of 5, with a maximum shift per employee of between 5 and 7, and per shift it needs anywhere between 3 and 20 staff at any one time. Right, that's quite a problem to have to manually work out. It would be even quite a task for classical or traditional compute to balance this, right? 80 staff with that many variables, that's a lot of compute. But if I run this, it will actually figure this all out for us. And it, you know, like I said, the pre and post processing is what takes majority of the time. And that's only because obviously I've got limited internet here, and that's what's causing the problem. But yeah, like this shows you here. So this is it completed. And obviously you can see that it's working out everyone who should be on a shift all the way down to the last person. Like I say, that's something that's not readily available, right? Like doing something like that is a lot different than what most compute companies will do. And with Dynex, we've barely even scratched the surface of everything that's quite possible. Recently, we've been really pushing to show as much as humanly possible, and I don't suspect that's going to stop anytime soon, to be fair.
Yeah, I mean, this is all sort of mind-blowing stuff here, and it's, I mean, like what you're getting. I mean, the cost benefit here is pretty amazing.
Yeah, the cost benefit truly does make it very attractive to a lot of companies, right? We've spoke to a lot of companies, and the first thing that they're blown away with is the price. They're like, well, it can't be that cheap, surely. Where's the hidden catch? Where's the small print that says we're going to get charged another 6 figures afterwards? And there isn't. That's the thing. There's not. We've built a business model around our plan and how we want to do it, and we think that we have the right idea with lowering the barrier, because the lower we make that barrier, the easier it becomes for people to get into quantum. The more people that are using quantum, the infinitely more busier that we're going to be as a network.
So how can people get how can people get started? Like where?
Sure.
What? Yeah.
So if you're a crypto person and you're holding Dynex and you wanted to use Dynex, if you go onto the Dynex 𝘂𝗽𝗋.org website, I'll actually bring that up. You'll see a link that allows you to go to our marketplace. Now, this side of the marketplace, the only way you can pay is in Dynex, because it's the crypto side of our business, right? The blockchain side. But if you're an enterprise level customer and a business wanting to get involved, then we actually have a specific enterprise level website. And again, that has a different wrapped marketplace that's developed not around the crypto side of the business, but very much focused on enterprise only. So it doesn't make huge references to crypto and blockchain. It's talking about distributed networks, and the wording's slightly different, and it's a little bit more technical inside. And because you'd expect that bigger businesses who have got quantum people on their staff, they're already going to understand a lot of this, whereas when it's from the crypto side, we've had to split the two, shall we say, so that we weren't mixing the wording for one with the other.
So I mean, that actually kind of brings to an interesting point. I mean, there's no doubt that once large enterprises or even universities that have their expertise and their level of knowledge is like way above the average person, could benefit from this. And it doesn't really take much pitching to them, right? But one area that I see a lot of potential, and it's something that I've been talking about for quite a while, is all these small to medium-sized businesses. So for those people that aren't necessarily like enterprise grade clients, is the platform like simple and easy enough for those people to use and understand and to plug in different models?
Yeah, I mean, actually, we've actually focused a lot of our wording, our help files, and also obviously we have our own team of Dynex experts as well, who are extremely knowledgeable coders who understand Dynex extremely well and have been vetted to the highest degree to be able to deliver that kind of service, right? So we have tried to make it as easy as possible. I'm always available for conversations and talks and meetings. We have a team of salespeople who are willing to, go and sit down with with companies, no matter what size they are. If they're interested, then we want to talk to them. No company size is a problem for us, right? That's why if you look at how our quantum packages are actually laid out, you can very much see that the $99 package is sort of designed at enthusiasts, developers, and very small businesses, like a couple of staff type size business, right? Then you've obviously got the two in the middle, which are designed for your small and medium sort of businesses, sort of your staff with, maybe 10 staff, maybe a couple of developers, that kind of business, right? And then you've got your medium. And then the 1 million quantum gates are for your, your big pharmaceutical companies, your academies for learning how to code, your universities and colleges as well, who are obviously very interested in it from an academia perspective. We've tried to make it so that there's a package for everyone. And the best bit, if you find that you hit that price point or you hit that barrier where you're just constantly at max capacity, then upgrading between packages is a seamless approach. The moment you upgrade, you instantly have that access unlocked to you immediately. So for companies that might be doing some sort of simulation, if they hit a bottleneck, they can make, one click on a button inside of our system and instantly upgrade and have that resource available to them at a moment's notice. So it really does
and that's pretty amazing. I mean, it's one of the reasons why years ago I was incredibly bullish about Palantir, because Palantir, a lot of their Foundry systems works out, their artificial intelligence works out different scenarios and different models that can help businesses. Like, okay, if event A happens, how is it going to impact the logistics, right? Like if there's a train wreck, and you could potentially use this live, your platform, because things are happening dynamically. And for instance, like that train wreck scenario, right? Something happens that could affect your distribution for your small to medium-sized business, and you want to know right away, okay, how is this going to impact us, and what do we need to do, right? And so you could plug in that scenario into your platform, correct?
Yeah, I mean, as long as you can code it in such a way that it's an optimization problem, and any sort of problem can be worked out to be an optimization problem. You just need to have all the variables to work that out, right? Sometimes you get a problem come across and you're like, it's probably missing a variable or two, and it turns out that those are the two variables that are skewing all your data, right? We've had that a couple of times, but that's the challenge for me, right? Figuring out how to optimize that as a problem on our network. We've had people come to us and ask about, security perspectives, what security concerns there are from a Dynex perspective. That's obviously something that's very much in my area of expertise. And we hear, oh well, if there's that much raw capability in quantum space, like how do you stop that being abused, right? And that's something else we've already put in place before we even launched our marketplace. We had that all figured out. We knew that we'd have to build out our own ethics committee, so a team of independent people that are, the definitive final answer, shall we say. If they turn around and say it can't be run, that's it. There's no way that we can override them. That's why they're there. But each of these type of services, though, and we see it with normal compute, right, that a certain level of responsibility comes with running these kind of services, that you do have to make sure that you're doing the right thing and make it ethically viable. And that's what we're all trying to do. We're just we're just taking a very different approach than some others lately, to be fair.
And
you're looking at our roadmap.
Yeah, so I'm here at your on your roadmap, and
Yeah.
you know, it just kind of goes through some of the stuff that you were talking about here.
Yeah.
And then you know, so this is that wallet that you were talking about. So that's in progress.
Yeah, that's gonna, so the node based wallet that is all run in your browser is actually a self-contained solution, right? It actually generates all your private keys locally. It stores them all locally in a very secure encrypted solution. And the whole concept is everything is done locally, even to the point of 2FA. It's all generated locally. So that's something that we're working on right now. And a few different sectors you can see there that we're obviously targeting actively.
Yeah, this aerospace, I mean, so like space is something that that I've been incredibly bullish on even before crypto. You know,
Sure.
I've been telling people that this is the next level of stuff. And you know, SpaceX isn't the only player in game. You know, I mean, space is going to be huge. I mean, it's an incredible opportunity right now. Yeah, I mean, you guys have checked a lot of boxes.
Yeah.
Amazon Marketplace listing. What is that about?
So I briefly touched on it earlier, where I said that a lot of people want that AWS approach, where they put their credit card or their bank details in, they hit deploy, and within a few seconds they can access the AWS services, right? Well, there's a way on AWS Marketplace to actually plug in outside options for them. So you can deploy like your own custom containers, or you can use a service that's on a Docker, for example, right? And and basically what we've realized is that if we open up that avenue, then it's another seamless journey for the end user, right? If they're already an AWS client using that service, they will now be able to deploy out a usable framework for Dynex to be computed on from AWS infrastructure.
And what's this system integrator?
Yeah. So what we've realized is that if we try and be the only ones onboarding our clients for us, right, we're going to need a staff base of probably a couple of thousand people at this rate, because I'm already doing 60 meetings a month. Sam's doing equally the same. Danny's doing even more and flying around the world on a frequent basis. Like, we realized that actually having system integrators, people that can actually help on board, and this is where the Dynex experts come in, right? They are our system integrators. They're the people that will spend the time with each client if they need it, give them that dedicated level of support, and make it a lot more streamlined process, right? Rather than them having to maybe wait a couple of days because we're all busy with other meetings that have been booked up. We can now obviously just request one of our system integrators to help.
And what's this this thing right here, this proof of useful work?
Yeah, so that's the absolute entanglement. So pure proof of useful work, or as I call it, absolute entanglement, because what we're going to do is all of the POW algorithm, the hashing, the actual way that it validates the blocks will be encapsulated inside of our proof of useful work mechanism. When a miner isn't on a job, effectively it will be helping secure the network at the same time. Even if it's just doing that side of it, it will still be proof of useful work at that point. And that's currently a lot further on than most people would realize. We've been doing research on this pure concept since at least October. So it's not like we have been rushing this. We're taking our time, because removal of certain hashing and then essentially retrofitting it into the proof of use or work concept, if we don't get that right, it will be devastating, right? From a corporate perspective, from a blockchain perspective, from a crypto perspective, it will be all kinds of bad, right? So we're taking our time. We're making sure that we do this correctly. Could there be some bumps in the road? I suspect so. This is a brand new actual concept being developed. Nobody's tried doing pure proof of use or work with a blocking hash, like block hashing, inside of that proof of use or work concept. So we're going to do what we normally do, and we're going to, you know, showcase what truly is possible if you just think a little bit more outside of just cryptocurrency.
Yeah, it almost, to me, it sounds like the way that you're describing that is Constellation's consensus mechanism, proof of reputable observation, where it's dynamic, but the nodes on the network are given a score based off of their participation. You know, so
yeah, the only difference
if
is
your node,
on a
yeah, so like if your node isn't online all the time doing work, you're not going to get the same amount of rewards as somebody who maintains their node and has, you know, like near 100% uptime, right?
Yeah. It'd be interesting to see when we fully go and turn all that on. It's going to be a real interesting time for us, because we will truly be going into the unknown. There really isn't something we can reference per se with how we're going to be running our hashing algorithm for our blockchain, as well as our jobs, all in the same kind of sphere, as it were. It's going to be really an interesting time. And then obviously there's the wrapped token as well. That's coming at the moment. We're just in the process of doing all of our auditing. So we've got an internal audit running and an external audit running. And once that's ready, then the bridge can go live. And that's a bridge to ETH.
About how many clients are actually using the platform right now, roughly?
What, from an enterprise client side of things, or from actual both sides? Because we do actually have a few developers who are using it from the crypto side as well.
Well, yeah, I guess in totality, like how many?
It's hard to say how many are actually dedicated, like using it right now, because we get a lot of trials going on at the moment. A lot of evaluations are happening. So if we take into the evaluations into the account, it's probably, you know, we've had at least, I would say, a couple of hundred people that would easily want to give it a test run. Now, whether they continue to use it, I don't know. That comes down to a lot of factors for the individual, right? They might get on it, realize that they can't quite do what they want to do compared to an actual quantum machine, and that's absolutely fine. But we would like to think that we can act as a very good stepping stone into quantum.
Yeah, and you know, here's kind of a cost comparison, I guess, if you will, between you know, your platform and, you know, IBM's. They're arguably the most famous quantum computing provider.
Yeah, I think the only other one might be D-Wave, is a very well-known quantum company as well.
Yeah, but I mean, this is just this image right here is you know, pretty mind-blowing, I guess.
Yeah, our number of qubits and quantum gates that we can actually produce will only increase the bigger the network is as well. So I remember when we were generating out the numbers, thinking it's going to get ridiculous if we were to say 5x the size of our network, right, from a distributed compute perspective. You can already see the numbers are going to get quite ridiculous in size. But I do love to see how much we've got access to. It's always nice to see it.
Well, we're coming up on time here. Just again, thanks for being here. Thanks for explaining everything. And is there anything that we could look forward to in the near future?
Yeah, we got a few bits that are on the way up. I know that some of our team are off to BTC Nashville at the end of the month.
Hit me up. I'm going.
Are you?
Yes,
perfect.
I'm going.
I'll make sure Dan comes and finds you.
Yes, absolutely.
I'll make sure he comes and finds you.
Yeah.
Because
he's got all my
based over in
contact
Colorado.
That would be amazing. I'm absolutely going to Nashville. So
yeah, no worries.
That'd be awesome.
We're also going to be heading to Token 2049 in Singapore.
Okay.
We're back out to Dubai as well. And then there's around November time, there should be a trip to Japan for us all as well that we've got to go and do. Because there's some big AI, blockchain, and quantum type event. It's like everything we do in a nutshell. So, of course, we got to make an appearance for that one.
Oh, when is that? I've always wanted. I've never been to Japan, and I'd like to go to Japan.
I think that if I remember rightly, let me stop sharing my screen a second. Let me just double check, but I think it is the 22nd. No, 20th to the 22nd of November. So yeah.
Okay. All right.
It's something I'm looking forward to, right? It's on my bucket list, Japan, to be fair.
Yeah, Japan is on my bucket list.
Anyone who likes the tech.
All right. Well, thanks again for the time and
thank you for your time.
Actually demoing this amazing technology.
All of
everybody, please follow Dynex and leave a comment below. And I want to do some more of these with you guys because this is some amazing stuff.
Maybe we'll get it set up so that you can run some demos yourself, and then that way you can actually have a play from an end user perspective as well.
Yeah, that would be good. I'll have to sort of think about, from just from my user perspective, like what I could do with it. As I've sort of scaled out, my works crypto side, because I've recently taken on a new position here as the marketing person for Stardust Collective. Maybe I could manage my time, optimize it a little bit better with your platform.
It'll give you a bit more of it'll give you a lot more clearer idea of what's capable of if you're able to play with it yourself, right? Sometimes it's nice showing it off, but it's even better to have a play with it. That's one of the reasons why all of our stuff is posted to our GitHub on a regular basis, so that everyone is able to try it for themselves, basically.
Yeah. Well, again, thanks for your time. And we'll do this again. Again, everybody, please like and subscribe and leave some comments below and let us know what you think. All right, everybody, take it easy.